All right, so 1c, just let's take a derivative, right? So we're going to bring our 5 down. So we're going to get 5x to the fourth over 5 minus 13 over 3 times 3x squared plus 36. So what can we do now, right? We can do some canceling. We're going to get an x to the fourth. Those 3's cancel, minus 13x squared plus 36. And can we factor this thing? Probably. So let's see, we need two things that multiply to 36, positive 36, that add to negative 13. So that's going to be negative 9 and negative 4. All right, so I have an x to the fourth here. How do I get an x to the fourth? Well, I multiply x squared and an x squared. Both of these will also factor, right? These are difference of squares. X minus 3, x plus 3, x minus 2, x plus 2. There's our derivative. So our critical numbers are just going to be x equals, right? Every 0 gets a chance, everything with an x gets a chance to be 0. So x is 3, x is negative 3, x is 2, x is negative 2. All right, so we're going to get at x equals negative 3, x equals negative 2, x equals 2, x equals 3. Now, again, if you know what these functions look like, it's going to be really easy to kind of see where we're increasing or decreasing. We have negative 3, negative 2, 2, 3. We have a fourth degree function who has a positive lead coefficient. So we're going to look like this. We're going to look like a W. Wu-Tang's for the kids. If we plugged in numbers, though, if we were unsure what this thing would look like, let's see. I'm going to just do, what's the best one? I'll do the x minus 3 one. All right, so x minus 3, x minus 2, x plus 2, x plus 3. Right, that's going to be our derivative. Oh, awkward. Got that. Got it here. And got it here. We even got one more in here. All right, so if I just plugged in something less than negative 3, like say negative 4, negative 4 minus 3 is going to be a negative. Negative 4 minus 4 is going to be a negative. Negative 4 plus 2 is going to be a negative. Negative 4 plus 3 is also going to be a negative. I have a even number of negatives, so this whole thing's going to be positive, so my function is increasing. If I plug in something between negative 3 and negative 2, like negative 2.5, negative 2.5 minus 3 is going to be negative. Negative 2.5 minus anything is going to be negative. Negative 2.5 plus 2, that's still going to be negative. Negative 2 plus 0.5 plus 3, that's going to be a positive. We have an odd number of negatives, so our derivative is negative, which means our function is decreasing. If I throw in something like a 0 here, I'm going to get a negative, negative, positive, positive. Two negatives. So we're going to get a positive function. So that means our function is going to be increasing. If I plug in something like 2.5, 2.5 minus 3 is going to be a negative. 2.5 minus 2 is going to be a positive. These are both going to be positive because we're adding. We have one negative, so our function is decreasing. And if I plug in something greater than 3, like 4, all of these are going to be positive. So we're going to be increasing. All right, so a lot of stuff going on here, right? So when we try to classify, we're going from increasing to decreasing, so that's a max. We're going from decreasing to increasing, that's a min. We're going from increasing to decreasing, that's a max. And we're going from decreasing to increasing, that's a min. All right, so a lot of intervals here, right? So negative 3 to negative 2. Also, 2 to 3, that's it. So that's going to be where our derivative is negative, so that's going to be where we're decreasing. We're increasing from negative infinity to negative 3. We're also increasing from negative 2 to 2, and we're also increasing from 3 to infinity. All right, so that means, sorry, that's where our derivative was positive, aka where our function is increasing, tomato, tomato. And so there's our increasing. Which critical numbers are the maxes? Well, we had x was negative 3. We also had x was equal to 2. our minima, where x is equal to -2, x is equal to 3. So to find these values, I'm going to just throw this to Desmos. I'm going to pause this so I can load up the function. All right, so here are all of the values, right? So here's our function. I'm just doing the values. So we have our mins, we have our maxes. I'm just going to cheat a little bit. I'm going to take this and I'm going to throw it into the notes and use that as my answer. And let's see. So what do we know? We got a -3 was a min, right? So sorry, this is a max. So we got a max, we got a min, we got a max, and we got a min. All right, so those are our points, our coordinates.